This is a lesson for Monday, 10/26. We're talking about quadratic inequalities this week, and we're going to be taking a look at quadratic inequalities with one variable. So we're talking about, instead of standard form being equal to 0, being less than, greater than, less than or equal to, greater than or equal to. So you can see the first example here. We are taking a quadratic equation being less than 0. And we're going to solve this the same way that you would solve any quadratic equation. But then we need to do one extra thing to figure out what the inequality tells us. And so you can see here that I'm going to take the quadratic equation and set it equal to 0. So we're going to ignore the less than symbol for right now and just treat it as if it were equal to 0. How would I solve this? And we would solve this by factoring. Factors of 4 that give me 3, x minus 4, x plus 1 equals 0. 0 product property. If I set each of these equal to 0 separately, I would get x equals positive 4 and x equals negative 1. So these are my two answers for x if it's equal to 0. But it's not equal. I want it to be less than 0. So these are not actually solutions to this inequality. They are just what we call the critical values. Negative 1 and 4 are what we call critical values. And so what we're going to do is we're going to take those critical values and we're going to put those on a number line. Negative 1 and 4. And then we're going to test each section of the number line. So I'm going to pick a number that's below my negative 1, like negative 2. We're going to pick a number that's in between them, like 0, and a number that's greater than 4, like 5. And we're going to test them. So I'm going to test negative 2, and to test it, that means I plug it back into the original equation with the inequality, and when I plug negative 2 in, I get 6. Is 6 less than 0? The answer is no. So because this number didn't work, no numbers in this section will work. And then when I test, get rid of some of this, and then when I test 0, when I plug 0 in for x, I would get negative 4, which is less than 0. So that does work. So that means every number in this section will work. And when I test 5, it doesn't work. So that means none of these in that section will work. So the only test point that worked was 0. So if 0 works, that means everything in this section will work. So that means that my solution is going to rest between negative 1 and 4. And I would write that, and here's the final answer, as negative 1 is less than x is less than 4. It's those and compound inequality statements that were and statements from Algebra 1. Another way you can write this is that x must be greater than negative 1. That's what this is telling us. And, you have to have the word and, x is less than 4. That's an alternative way to write the solution. But I think this one is better. Some people have trouble with testing critical values, so I'm going to pull back and try it again from scratch. Once I've gotten my two values by solving by factoring, right here, what we do, and I'm going to run through it again from the beginning instead of just seeing it here, is that I take my two values, negative 1 and 4, and I put them on a number line. And I have three regions. The answer could be, and actually I'll tell you this, it's going to be one of two things. It's either going to be the two outsides as an or statement, or it's going to be inside as an and statement. So it's going to be one of those two options only. So we test and we just pick numbers. They pick negative 2, but you could pick negative 5. Just as long as it's a number that's in this region below this critical value of negative 1. Here's my two critical values. And it breaks the number line up into three regions. So pick any number in the left region. Pick any number in the middle region. Well, 0 is the easiest one. Pick any number in the region to the right. And I can pick a number, I don't know. I mean, they used 5, but I could pick 10. Any number in that region to the right of 4. And again, we plug those in. So if x equals negative 5, I take my original equation and I plug negative 5 in. Negative 5 squared is 25. Negative 3 times negative 5 is positive 15. Minus 4 is 40 minus 4, 36. Is 36 less than 0? It is not. That is not true. So this is not the right region. And you could test 10, but if this side doesn't work, then this side doesn't work either. It's not the outside, and you can pretty much assume that it's the inside, but you do need to check it. Let's plug 0 in for x. 0 squared is 0. 0 minus 3 is 0. Minus 4. So I get negative 4 is less than 0. That is true. So that means this is the region that is the correct solution, not the outside regions. How do you represent this blue shaded region? You represent it by saying that it's between negative 1 and 4, that x is between negative 1 and 4. Okay? There is another way to check these, so they give us another example. And we're going to do quadratic formula tomorrow. I think I'm almost positive your homework tonight is all factorable, so you can solve them all by factoring. We'll talk about this more tomorrow. But you could check this on the calculator instead of doing a number line. If you graph this in the prism, you would see a graph that looks similar to this. And then you can say, okay, well, I want it to be greater than 0. Okay, where is it greater than 0? I don't know. But if I treat 0 as y, and I say y is, now read this backwards, less than or equal to 3x squared minus x minus 5. What does less than mean? That means I'd be shading below the line. And if I shade below the line, that would fall outside. A lot of people have trouble with that, so I wouldn't recommend using what example 5 shows. I would stick with the number line. But if you want more of an explanation about how to use the prism to check it, pop back into the live session and I'll walk through it with you if you want to try what example 5 is showing. But I would stick with this number line. Pop back in if you have questions, if you need me to explain anything. Otherwise, if you're good, start the homework.